I want to go through one more time here Punnett squares, just so that you're aware, or maybe just get a little more practice with these. And we're going to do another dihybrid cross, which means we're going to look at two different traits. The classic example we've been using in class was brown hair and blonde hair would be one trait we've been looking at, and then what kind of eye color. Is it brown eyes or blue eyes? So let's do another one here, just to mix it up a little bit. Let's say we're dealing with a frog now. This frog has a dominant trait here of either green skin would be the dominant, or let's go with a yellow skin here. So we'll say yellow for the recessive trait, and we'll say green here for dominant. And also we'll go with a let's pick a spot. So I was going to do spots, but I don't want to use an S because of the shape of the letter here. But so let's throw a T out there. If it is a dominant, it means it's going to have spots. And if it's recessive, we're going to say no spots whatsoever. Okay? So if I was to ask you on a test, and you're probably going to see something like this, either on a quiz or a test in the near future, in sentence form, I'm going to say, what kind of, try to figure out the genotype for two parents, and then take those two parents and cross them to try to get their offspring. So if I said there's a green frog, a heterozygous green frog that has spots, we're going to assume one of two things. Either it's heterozygous, so a capital G, lowercase g, because that dominant trait is still showing, or it's going to be homozygous dominant, where we have two capital G's. And I said heterozygous right away, so we're going to say, okay, that's that. And we're going to say it has spots, and for this case, let's also say that is heterozygous. Okay? And if it is heterozygous, I will give you that information, typically, because that's something it's hard to assume without really diving into it. And that's going to breed with a frog here that has, let's go with yellow skin. So that's got to be homozygous recessive, because there's no dominant greed trait to get it. And we're going to say that this one also has spots, and they happen to be homozygous dominant. A little different. Okay? So right now, if you're following along, make a note of the things on the left side of this table here, or the left side of the page, these four things, because I'm going to erase them here in just a second. So if you haven't got those down to memory yet, please do so. All right, so we are going to do a dihybrid cross, which means we're going to have to use 16 squares, that big Punnett square here. And the FOIL method's been working for some of you. Some of you are just taking it one letter at a time, which is also fine. When we look at the first parent over here, this parent, remember, we have to, with every time we see a reproduction here, we have to pass on one allele, which is a letter, one allele for skin color, and one allele for spotting, if it's got spots or not. So that means we always have to pass at least one G, and we always have to pass one T over. You can't pass two G's, or you can't pass two T's. You have to have one or the other. So the combination here, we'll start with the capital G. Let's just look at the capital G here. Capital G can be one of the two skin colors passed on, and it's either going to be paired with a capital T or a lowercase t. So let's start there. So we got a big G, big T, or we got a big G, little t. Then you take a look at the lower G here, or the lowercase g. That can either have a big T to it, or it can also have a little t to it. So little g, big T, or little g, little t. Okay? We can do the exact same thing over here if we want to look at the combinations. Now this one's a little bit more simplistic because you only have really two combinations, but for all practical purposes here, let's write it out like we did the first time. This little g is either going to be sent on with the big T there, or it's going to be sent on with the big T here. So we'll put those down. for the second parent, or we're going to see it, little g here, it's going to go to the big T, or it's going to go to this big T. We have our Punnett square set up now. Okay. Now I'm just using colors to represent the different combinations we could possibly see. You do not have to do this, but it would help if if you're struggling to find where these alleles go. Color is always a good visual for people. So, looking at our Punnett square, let's fill in what we can. If we go to the first box up here, we're going to put our allele combinations back together because I do want my boxes to look like what we're seeing with our original here, which means that big G, or that the G's are going to come first. Okay? So in the first box, we're going to have a capital G, lowercase t, capital G here, lowercase t here, and then we happen to have two big T's. Go over to the second box. Got a big G and a little g again. And then I have a tall T and a short t, or uppercase T, lowercase t. Go to the third one. Now I have two little g's in that case and two big T's. And the last one, we're going to see two lowercase g's again, and a capital T and a lowercase t. Okay? Now, you can do the same thing as you go throughout here. Maybe one thing you're noticing, some of you, they're starting to get more comfortable with this Punnett square deal, is what do we notice about this parent, this column for this parent? Hopefully you notice that this column, we are seeing they are all the same thing. Everything's the exact same thing. So what we can do is just assume correctly that we can just fill these all in. They're all going to be the exact same. Which is kind of handy. Stuff we've been working on in class doesn't always work out this way. So now the question then arises, well, what is my genotypic ratio? And what is my phenotypic ratio? My genotypic ratio is going to be what are my different letter combinations. Remember, we're talking about the genome, we're talking about the allele combinations here, the letter combinations. Well, if you look closely, you're going to see that we have four different ones. I have a big G, little g there, and then I have two big T's. Here I got the second column, I have a big G, little g, and a big T, little t. Third column, I have two little g's and two big T's. And the fourth column, I have two little g's and a big T, little t. So our genotypic ratio, I'll just abbreviate here, would be 4 to 4 to 4 to 4. Okay, so I have 4 here, I have 4 here, I have 4 here, and I have 4 here. Now, we said in class, I want this simplified though. So the ratio would really be, for every one of the first one, I'm going to have one of the second. For every one of the first one, I'm going to have one of the third. And the same with the fourth. So my ratio here is 1 to 1 to 1 to 1. Okay? The phenotype ratio doesn't always have to match them, as we've seen. So we'll go pheno ratio. In this first column here, this one right here, we see a big G and a little g, heterozygous. That means we're going to have green skin. Green skin, and we're going to definitely have spots because we have a homozygous dominant here. So we have green skin and spots for column 1. Column 2, heterozygous, heterozygous. So in a sense, these ones are the exact same. Even though their letters aren't the exact same because those dominant traits are there, they will be the same. Third one over. We have two little g's now, and we have a homozygous dominant with the spots here. So now we have yellow skin and spots. It's a little different than the first two. Over here, homozygous recessive. means yellow skin. You look over here again, not the same as what we saw in column 3, but it's heterozygous, so therefore we're going to have spots again. So now, instead of what we saw with the genotype ratio, we actually have these two columns here and these two columns here being the same thing, which gives us a phenotype ratio of 8:8, or more simply 1:1. Now please, when you're doing this, make sure you let us know what that 1:1 means. You know, is it, in this case, I guess would be green skin and spots is one phenotype, and then the other one would be yellow skin with spots. Okay? And if you look back to our original diagram, or our original parents, the reason we're seeing spots in every single one of them is because we have a heterozygous here and we have a homozygous dominant there. And that homozygous dominant right there is taking care of spots. We're getting spots no matter what in all 4, or in all 16 boxes. Okay?